Hey nerds, so I'm going to talk about my favorite person to criticize, pseudo-intellectual crackpot and former clinical psychologist, former Dr. Jordan B. Peterson. And I'm going to talk about me actually agreeing with something because he is actually agreeing with Foucault, my favorite 70s pervert post-structuralist philosopher who he strawmans all the time, who in this video he doesn't have, he's completely oblivious to how much he actually agrees with post-structuralists like Foucault's perspectives on truth and scientific facts, and they sound like literally exactly the same. So this is an old lecture of his, but he just reposted it on his YouTube channel like a few days ago. So we'll get into it. And he's talking about John Piaget, who he doesn't reference so much anymore, but he used to reference him a lot, and he was like like an expert in like child psychology and developed this theory of the different stages of maturation and in childhood, that sort of thing. So we'll get into it here.
One way of looking at science is that it's a collection of facts, right? That's what Piaget is stating to begin with, and that we assume that the facts that science has gathered are facts and static. But if you observe them across time, what you find is that scientific facts tend to shift and transform, because scientific theories that are applicable in one century, let's say, turn out to be less applicable in the next. Now, there's been a lot of argument and discussion about this, because the fact that facts change seems to indicate that they're not so self-evidently facts. And there are people, and perhaps Kuhn would be among them, who believe that science consisted of the juxtaposition of paradigms. So those are sets of axioms within which something operates, and the paradigms, he considered them often incommensurate. You couldn't move from one to another because the axioms were different. There was no necessary, no, what might you say, there was no necessary means of communication between them. But and Piaget knew of Thomas Kuhn's work. That's the scientific structure.
So yeah, this, oh wait, he's going to go into that.
Of Scientific Revolutions, which was published in 1962. It's a classic text in the philosophy of science. And
yeah, Structure of Scientific Revolutions by Thomas Kuhn. That's a very well-known book that, you know, it's like it's not a critique of science. It's basically it's putting forth the argument that he's talking about, which is that scientific facts can change, and the scientific consensus changes much more gradually, and some people have to die for new theories to be accepted and that sort of thing. And this is, like I said, he's completely oblivious to the enormous degree to which he agrees with post-structuralist philosophers like Foucault and Derrida on this subject in terms of science and facts. Like, they still believe that there are scientific facts, but they're not sure whether objective truth actually exists or not. Like, obviously there seem to be static, like strong nuclear forces and gravity and electromagnetism, the four main forces of the universe. They tend to be static and unchanging, but it was only very recently in human history that we discovered gravity, so we didn't think, we had all sorts of alternative theories about that turned out to be completely wrong. We can talk about like the heliocentric versus the geocentric model of the universe, where the like, we used to think that the universe revolves around the earth, and then we found out that the universe revolves around the sun, and then, you know, there are famous scientists executed for that, and we can get into that. And so we don't really know the degree to which scientific facts are going to change in the future. That doesn't mean that there are no scientific facts. It means that scientific facts are true until we find out more about them, and we can assume that they're true until we find out that they're incorrect. That's where he goes wrong now. He says that, like, he'll say scientific facts change, therefore God is more real than real, and but then he gets all like, basically, it's objectively true that, you know, the vaccines are not all good, they're really bad and stuff. And he'll believe in objective truth in that sense. But then if you ask him about whether he believes in God, do you believe in God? He'll say, well, it depends on what you mean by do, and what you mean by you, and what you mean by believe, and what you mean by in, and what you mean by God. And then if you talk to him about climate change or vaccines, he'll say, no, those are objectively satanic, man. So of course, he's a hypocrite like everyone, but he's way more of a hypocrite than he should be, especially for someone who's supposed to be this world-renowned intellectual. But just that tangent aside, this sort of video is why he used to actually make good points. It's because he didn't realize that he was actually agreeing with people who he was criticizing, because even back then he was maybe more inquisitive and read more, but he still did not actually know what he was talking about with a lot of different intellectuals, in spite of the fact that he did make some good points.
And what Piaget assumed more was more like I would say more like a classic view of science, where, so for example, when Newton came up with Newtonian physics, there was a set of propositions upon which Newtonian physics was based, and then when Einstein transformed those propositions, what happened was that Newtonian physics became a subset of Einsteinian physics. And so the way that Piaget looked at the development of factual ideas, at least in part, was that you'd come up with a set of ideas that were facts, and then that would be superseded by a different theory within which that original theory would be nested. And so that what happens that each theory, in some sense, although it transforms, it becomes more complete as scientific progression continues. Now, Kuhn didn't precisely believe that, although exactly what Kuhn meant by a paradigm shift, because Kuhn originated that term, isn't clear, but he didn't seem to actually believe that science had this capacity to present a series of facts and then alter the underlying presuppositions and then to nest that within a broader series of facts, like you would assume if you were thinking about the relationship between Newton and Einstein. So Newtonian physics is a subset of Einsteinian physics. So now that's kind of how Piaget thought about how human beings develop knowledge. He believed that we came up with well, let's say you wanted to chop down a tree. That might be a good example. I mean, you could use a dull axe made of bronze. And it's like, well, that would chop down the tree. It'd be a lot of work though. And then maybe you replace that with a sharp steel axe that's designed like a wedge so that you can really hack down a tree with it. Or maybe you replace it with a saw. And so it's not like the bronze axe couldn't chop down the tree, but the steel axe can do a better job, and the saw can do even a better job. And so the way that Piaget thought about the transformation of human knowledge structures from infancy onward essentially was that infants would produce a representation of the...
In this context, though, Piaget is talking about the evolution of knowledge. Maybe evolution is the wrong word, but like the development of knowledge structures in terms of like during the process of a child's upbringing, the way that they understand knowledge and how their understanding of knowledge like change and evolves, basically, so to speak. And so it's not exactly the same as how you look at scientific facts and what scientific facts are. It's about how the way you look at them changes. But in a way, that's also related to his point, because we learn that scientific facts are wrong because our perspectives on them change, which is how we learn new information, which is how we learn new scientific facts that overturn old scientific facts.
The world that was sort of low resolution but quite tool-like. It would work in the world, but then as they progressed, the nature of those tools would become refined and sometimes transform completely. So sometimes you imagine that a child would use, in a
exactly what I was just talking about, right?
And it's a low resolution picture of something, and then they would increase its resolution as they filled in the details. That would be assimilation. That's the Piagetian notion of assimilation. You're using the same basic theory but filling in the details, and then now and then you'd have to switch to another picture entirely, and that would be more like accommodation. That's where you'd have to transform your internal structures.
Like if we're talking about that in terms of, like, I use the word evolution, for example, Darwin, he didn't necessarily discover evolution. We talked about in one of my videos on a Foucault book before, Lamarckian evolution, and he was one of many people who theorized about the concept of evolution before Darwin popularized the idea and did a bunch of research on it. But the point is that after Darwin and our Darwinian evolution by natural selection. Since then, biology has done a lot of work in terms of filling the gaps of the scientific facts involved with biological evolution.
Completely, in order to properly represent and act within the world. And so that's the basic difference between accommodation and assimilation. So assimilation is like micro alterations, and accommodation is transformation of the knowledge structure itself. And so that's part of, so what Kuhn pointed out was that there'd be a set of facts, and then there'd be an anomaly arise of some sort. So like at the end of the 19th century, the only remaining anomaly was, at least one of the remaining anomalies was that no matter which direction you shine a light beam in, and no matter how fast the platform on which you're standing is moving, the light beam has exactly the same velocity, which seems impossible. So, you know, if the Earth is moving this way around the sun, and you shine a light off the Earth, you'd expect the speed of light to be the speed of light plus the speed of the Earth. And then if you shone it the other way, then you'd expect the speed of light to be the speed of light minus the Earth's speed. But that isn't what happens. No matter how fast the platform on which the person shining the light is standing, the speed of light is always the same to every observer. So, and people kind of thought of that as, that wasn't the only anomaly, but that was one of them, thought of that as the only anomaly left in physics at the end of the 19th century, and turned out that was a bad one. Along, there were some other ones as well.
I think he means like the speed of light doesn't actually look the same to all observers. It is the same regardless of your observation. You can observe it differently in the speed of light. An object moving at the speed of light can look differently to someone than it can to someone else. I mean, if we can actually even see it, which maybe, I mean, maybe we can't, but I think I don't think he means that we perceive it differently. It happens the same way regardless of how we perceive it.
Like the fact that light tends to behave as a wave and a particle more or less at the same time, which doesn't seem possible. So there's a couple of things left over in Newtonian physics that the Newtonian physics couldn't explain, but by the end of the 19th century, there were famous scientists saying, yeah, well, we got this all wrapped up. There's really nothing left to discover. And then along came quantum mechanics and Einsteinian relativity, and
that's
bang.
like, that's, you know, as Thomas Kuhn was talking about, that's the structure of scientific, part of the science is the structure of scientific revolutions. A field of science thinks we figured everything out. All we need to figure out is the little details left in the main theory that objectively tell us everything we know about this particular field, like evolution, like biology or physics or anything else. And then there's like a big breakthrough, and we find out, oh, there's this new thing called quantum mechanics. So we have to rethink the way we think about physics and separate it into two different types of physics. And Newtonian physics is still used for a lot of things in the real world, and even in I think larger objects in space travel, if I remember correctly. And quantum mechanics is used for like small like things that are much smaller measurements, and you use them in technology like satellites and so on, and that sort of thing, as many people have talked about.
Bang, the whole world was like really different. And quantum mechanics is much more comprehensive theory of the world than Newtonian physics. All of the electronics you use wouldn't work if quantum physics wasn't correct, roughly speaking. And so that little tiny anomaly blew into something that knocked the slats out from underneath the entire axiomatic structure of Newtonian physics. It showed it was wrong at its fundamental levels, even though it turned out to be a correct subset of something that was much broader. And so you can kind of think of that as,
correct subset of something that was much broader. Not that it was necessarily wrong, but it was wrong in terms of measuring the things that it turned out quantum mechanics was way better for measuring.
What kids are doing as they progress, they develop a theory that accounts for a certain set of, you could say, facts, but this is another place it gets tricky. And then they modify those and make them more and more refined, but now and then they have to undergo quite a transformation. That'd be a stage transition in Piagetian thought. That's the stage transition idea. And that would be akin in some sense to a Kuhnian scientific revolution. Now, what Piaget is trying to state here is that because there's this weird problem with facts, which is that they tend to transform across time. You know, like if you go take a biology course right now, in 20 years, pretty much everything you learned, or very much of what you learned, will turn out to have been wrong. And that's kind of weird.
Like that's standard Peterson hyperbolic rhetoric there. Like, I think it's still true that most of our basic biology and human anatomy, like our knowledge about that, has like remain fairly similar for a lot of the modern era, let's say, and we've discovered more and more details about what it's actually like and the complexity and all that kind of stuff, and we're still learning more and more. That doesn't mean 70% of what you learn will be useless, but I mean, I see his point.
Weird, because it isn't wrong right now, and you think, well, how can it be wrong in 20 years? And that's a really complicated problem, and
It is actually.
in order to solve that, you kind of have to think about facts like tools instead of them as thinking about them as objective independent realities, because
that actually is that doesn't mean that you should be like a moral relativist or anything, like truth, like, or I guess that's maybe more of like a pragmatist version of truth. Like truth is this is true if it's useful for this particular thing now, but it's no longer true if it's not actually useful for this. That's a way of looking at it. It's not like manipulating facts and just saying lies if a lie suits your purpose. It's that it's looking at them in terms of what the fact is useful for. Like, you know, the theory of gravity is useful for flying and figuring out how to manipulate objects so they can fly, and figuring out that humans can't jump off a cliff and be able to fly and that sort of shit. But they're like, it's useless in other contexts, and maybe it'll turn out to be that the case that gravity is actually not what we're really studying. We're studying something different because gravity and quantum mechanics are incompatible, as anyone who knows, like, you know, has read popular books about physics knows. So, you know, maybe these facts, like he was saying at the beginning of the video that Thomas Kuhn was saying, the nature of scientific facts can change as we discover new information.
a bad tool can still work as a tool, whereas a bad fact just kills you stone dead. Okay, so here's one of Piaget's propositions.
It doesn't have to, though. Like he was talking about, if you look at it as a tool, a fact doesn't have to kill you stone dead. If you think that like what he says, all of the facts that he's gotten wrong about vaccines and shit, those facts didn't necessarily kill him, even though they very easily could have. And, you know, his incorrect facts about climate change don't really have any direct effect on him personally either. So, you know, he's hyperbolically proving his future self wrong in that sense here.
And it is that because facts flux in some sense across time, you're looking for something that doesn't change across time to call it a real fact. And so what Piaget is trying to point out in this, let's call it introductory paragraph, is that the one thing that doesn't change is the manner in which people generate facts rather than the facts themselves. So the ultimate fact is a fact about the way people generate facts.
See, that makes sense, right? That's actually a pretty keen observation,
right? And so Piaget's theory in part is a theory about how knowledge is acquired and transformed. And so it's not a study of the knowledge itself, it's a study of the process by which the knowledge is generated. And he believed that process was unchanging, at least with regards to human beings. And so
that's almost right out of what Foucault would say. Like, what's more important than the actual knowledge itself is the way we understand the knowledge, or what's more important than truth or scientific facts is the perspective we use for understanding truth and scientific facts. Like exactly what he was saying there in terms of what Piaget's argument is in reference to Thomas Kuhn's structure of scientific revolutions.
Could think of the Piagetian genetic epistemological mystery as being, how is it that people form and transform representations of the world? And one of his conclusions about that is that there's a standard process.
So yeah, like I said, this is actually interesting, and I was debating about what to call this video. I decided to call it Jordan Peterson's Right, because it's one of the rare times when I agree with him. But the interesting, I think, is fascinating. I agree with him because he doesn't realize that he's wholeheartedly agreeing with evil postmodern neo-Marxists like Foucault and Derrida about the fact that scientific facts are not static and truth and scientific facts actually change. The scientific facts do not remain static. They change. Good job, Jordan Peterson. Spoken like a true postmodernist.